question now, which says if 20 cm cube of sodium hydroxide was neutralized by 20 cm cube of 0.01 mole per dm cube tetraoxosulfate 6 acid, he said, what is the concentration of the solution? So this time around, the concentration we are looking for will be the concentration of the base. Concentration of the base. So, and we already know the formula to use, which is CAVA over CBVB equal to NA over NB. And with this, we can write the equation of reaction, that is H2SO4 plus NaOH to give us Na2SO4, plus water. So try to check this equation. Can any one of you tell me whether it is balanced or whether we need to balance it? Is the equation balanced?
It's not balanced.
Okay, how can we balance it?
Sodium is 2 at the
2 at the
product
outside.
side, but at the reactant
Yes,
side it's 1.
yes. So we have to put 2 here. And hydrogen is 2 at the product side as well. Then it has become 2. Then is the oxygen
Yes,
balanced? 4
yes,
here.
it's balanced.
Oxygen is 6 on the left side, right? Oxygen is not yet
Oxygen is
balanced.
5.
So probably if we put 2 here, is the hydrogen now balanced? Hydrogen is 2
No.
here,
Yes.
2 here, 2 here.
Yes.
That's 4. It's now balanced. So that means Na over Nb, acid is 1 mole, then this is 2 moles. So Na over Nb will be 1 over 2. So what is the concentration of the base, of the acid that we are given? 0.01. That means 0.01 times volume, which is 20, then over Cb that we are looking for times the same 20, which is 1 over 2. So 20 can cancel 20, then you have 0.01 over Cb equal to 1 over 2. So when you cross multiply, you have Cb equals to 2 times 0.01. Okay. So what is 2 times 0.01? Cb equals to 0.02 mole per dm cube. Is this clear to you?
Yes, it is.
Okay, Sarah, is this clear? Sarah and Mercy, is this clear?
Yes, sir.
Okay, good. So the next question is for Moses, while number 3 will be for Mercy. So for number 2, this one is not a calculation stuff, it's just a principle stuff. So let's see. Check this Moses and read it.
Electrons always occupy the lowest empty energy level. As a statement of electrons always occupy the lowest energy level as a statement of A. Afubra principle.
Aufbau, right? Yeah, right. Aufbau principle.
Afubra.
Aufbau principle. So, Aufbau principle states that the electron fill the lower energy atomic orbitals before filling the higher ones. So, um, and what are the energy levels that we're talking about? Do you know the energy levels we're talking about?
Yes.
What are they?
KLMN.
KLMN.
LMN.
It goes like that. The
Okay.
energy of that.
Okay. Um, the next one is for Messi. Like I said, it's not a calculation question as well. It's a theoretical or principle based. So, Messi, read this.
Which, which of the following metals does not react with water to produce hydrogen? Copper.
Copper, how and why?
It does not react with does not react with water to produce hydrogen.
Why?
That means it does not react with water. It does not dissolve in water.
Okay, let us state this question this way. Copper does not react with water to produce hydrogen. Explain. So what will
I
you
don't know how
say,
to
Messi?
explain it.
You
So
said
I shown
what?
that does not react with so I shown you that does not
For copper to react with water to produce hydrogen, copper must be able to displace hydrogen. Moses, what did I say?
Copper hydrogen must be able to displace hydrogen.
For copper to react
Yes.
with what?
dissolve.
Listen carefully. I will ask Messi, I will ask Sarah. So sit up and listen. For copper, this one that Sarah is sitting as if she's watching what's the name of this latest series? Indian
So
you're watching Z World.
maybe land.
Okay, listen. For copper to react with water to uh, produce hydrogen, it means copper must be able to displace hydrogen in the compound. So, but how do we know whether copper can displace hydrogen? That's my question to Messi. Yes, Messi. How do we know whether
How
copper can displace hydrogen? What are we going to know? What is going to tell us if copper can displace hydrogen? Yes. Okay. What we need to consider is the electrochemical series. You've heard of this before, yes or no?
yeah.
Have you all heard of this electrochemical series before?
Yes, sir.
So, what are the members of the electrochemical series? Can you list them in order? Maybe from increasing
This number.
from the highest electropositivity to the lowest electropositivity.
Potassium. Potassium.
Lowest electropositivity. So, what should be the first member? The highest.
Potassium.
Okay, maybe we should rotate it. Once you mention potassium, which is Okay, let Messi give me the next one in this series. Messi, what should be the next one? Then Sarah will give me the next one. Yes. What should be the next one, Messi? Okay. You don't know it? Sarah, look up. What should be the
So
next
it's
one?
calcium.
Calcium. Okay, is this Sarah that gave the answer to this one? Is this Sarah that gave the second answer?
So it's sodium is second one.
You said, okay, sodium should be the second one, right? Okay. Now, Sarah, what's the third one?
Calcium.
Calcium. So, Moses, what's the next one?
Magnesium.
Okay. Messi,
I don't know.
Sarah, hmm?
Phosphorus. Aluminium.
Hmm?
Phosphorus.
Okay, I think I've modeled up something here. So let me reduce the sizes so that it can contain all of this from the aluminium. Let's see. So we'll go back to so the list aluminium, zinc. Which one is this one? Which element is this, Sarah?
My voice is breaking.
Which element is this, Sarah? Okay, I think there have been a network issue there. So I was listing the what's it called? The electrochemical, the members of the electrochemical series. I was asking Sarah a question, but she isn't responding. Sarah, which element is this? She's not even looking up.
Tin.
Is she feeling unwell?
Which is
Yes.
Yeah,
Tin.
tin, tin. Okay. So
Yes.
please focus on this: aluminium, zinc, tin, then lead, hydrogen, copper, mercury, silver, and gold. So if you know the name of all of these elements, this is from the highest to the lowest in electropositivity series. Okay, is that clear?
Yes.
yes,
Yes,
sir.
sir.
So we have
So I've told her. No, I've told her she's not here.
so we
Message is
have
ended.
now listen. We have I want to give you a kind of an acronym or like a sentence that you can use to remember all of this. Okay, you can say Peter Sampson can manufacture all zinc in the lab. Peter Sampson can manufacture all zinc in the lab. However, complicated matter seems going. However complicated matter seems going. So if you remember this sentence, Peter Sampson can manufacture all zinc in the lab, however complicated matter seems going. Then you'll be able to know that this is potassium, okay? And this is sodium, Sampson.
Yes, sir.
This is calcium, magnesium,
Because Nancy
aluminium,
can manufacture
zinc,
Peter Sampson
iron,
zinc in the lab. How
tin, which is Sn, lead,
Mr. Mr.
hydrogen,
Sir,
hydrogen.
hold on, oxygen,
Oh,
I say oxygen, copper, mercury,
it's too long.
silver,
H,
and gold.
U.
So Peter Sampson can manufacture all zinc in the
Mr.
lab. Yes, what you are saying something?
Sir, I have another selection. This one is too long. I have
Hold
a
on, calm
simpler
down.
one. I'll continue.
Hello. Listen, calm down. It's only a sentence. Peter Sampson can manufacture all zinc in the lab. However complicated matters seem going. So any other acronym
So
you
what
want,
sentence?
listen, Mercy, are you listening to me? Are you listening?
Yes, yes.
So any other thing,
Yes,
this yeah, this is not compulsory, okay? I'm only showing you what to use in memorizing this. So if you already have one, it's not a crime. Is that clear? Is
yes,
that clear?
sir.
So you don't need to use that to distract the attention in the class. For example, so I just use this to show
Yes,
you
sir.
how
Yes,
you
sir.
can, let me
Mr.
see.
Peter Sampson.
I have removed it, right? Because you said you don't need it, that's why I remove it, okay? Or Moses, do you need it?
Yes, so I need it. It's only message that don't need
Oh,
it.
the move is simpler.
Sound better.
So
Sentence.
it's back
It's a
there,
sentence
okay?
too.
No.
Hello, calm down. Mercy, calm down. So
I
back to what
MSc.
we were, talking about. Because hydrogen is lower, I mean it's higher than copper. Copper is higher than hydrogen, lower than hydrogen. Copper cannot displace hydrogen. It means that potassium can displace all of them, okay? Sodium can never displace potassium. Take note. But sodium can displace the rest. Calcium can never displace these two. Is that clear? But calcium can displace the rest. Magnesium will not displace these three, but magnesium can displace all of the rest to, produce those elements when it meet them in a compound or in a reaction. That's why we say which of the following metal does not react with water to produce? It does not mean they do not react with water. It means they cannot produce hydrogen when they react with water. Maybe if water contains something else, they might react to produce another thing or just to form a kind of solution or something. But now, what's it called? Copper cannot produce hydrogen. Why? Because copper is lower than hydrogen in the reactivity series. In the what?
Activity series.
Messi, back to you. Explain to me now, why is it that copper cannot displace hydrogen or cannot produce hydrogen when it reacts with water?
Because copper cannot displace hydrogen in the radioactivity
In the
series.
reactivity series, because copper is
Reactivity.
yes, copper is lower than hydrogen in the reactivity series. So that is the
Yes.
okay. The next question is for who? Who's supposed to answer the next one?
Sarah.
Okay, that's Sarah, right? And
Sarah.
this is Sarah that is
Yes, sir.
sleeping and she wants to dream. She wants to go
She
to
also
the
like what? Of our mother's land.
so Sarah, over to you. Read this.
To you.
Sarah, I'm waiting.
So the answer is C.
The answer is C, right? Explain. Why did you choose C? How is it C?
Just explain it now, Peter. Something. Hmm.
Wait. Which of the following you don't even I said read the question. Did you read it to me to hear for me to hear? No. So which of the following arrangement of elements is in decreasing order of electronegativity? I just showed you positivity. So if positivity is decreasing towards the right in what I showed you above, then that means it is the same as increasing electronegativity. So if you look at it from top to bottom, electro positivity is decreasing, okay? The same top to bottom means that electronegativity is increasing because from bottom to top will be increasing positivity to the highest. Is that clear? Then if positivity is increasing, that means negativity is decreasing, okay? So let's now consider these options. Can you hear me?
Yes,
Can you
sir.
hear?
Yes.
Good. Now, let's consider this last option. We can see sodium, magnesium, and aluminium. So that means sodium is higher than magnesium, and magnesium is higher than aluminium. We might never, say anything concerning this. But let us now see, let's consider them. In sodium, we have sodium, we have 281. In magnesium, what do we have? 282. In aluminium, what do we have? 283. In silicon, what do we have? 284.
That's
Phosphorus is
15.
number 15. What do we have?
25.
285. So you can see 1, 2, 3, 4, 5. The the most positive there is this one, okay, because you can donate one electron. Then followed by these two that will donate two, followed by these three, and so on. So if you are looking at the decreasing order of electronegativity, you start from the highest electronegativity. Phosphorus here is the highest, okay? Highest negativity.
That's
And this is the lowest negative. Is that clear to you?
Yes, sir.
So that is why the option is D. Okay, who's supposed to answer the next question? Who answers the next question? Is it Sarah or Moses?
yes. Yes.
Moses, okay. So, Moses, over to you.
Magnetic bond in magnesium is stronger than that in calcium because magnesium has a larger atomic size, smaller atomic size,
Who is
greater
that?
number of valence electrons, lower melting point.
Who is that?
Mm,
So, which
Metallic
Who is
bond
speaking?
is stronger. The elemental bond, magnesium and calcium.
I
These are smaller atomic size.
small atomic, smaller atomic size, right?
Yes, sir.
I think that's correct. That's correct. So, the further explanation to that will be the what accounts for the atomic size, whether small or big, is the radius, okay? The atomic radius. Is that clear? So
Yes,
Yes.
magnesium
sir.
has a stronger metallic bond than calcium because that's a smaller atomic radius. Then atomic radius decreases across a period and increases down the group. That means calcium has a larger atomic size. Okay. Okay. Are you hearing that?
Yes, sir.
I mean calcium has a larger
Yes, we
atomic
are.
size. So let's see. The next one. Okay. The next one is for
Messi.
Messi. Okay.
Messi, yes, Messi.
Why used to this?
So Messi, here comes your question. Let's see. Read this, Messi, and provide your answer.
Consider the reaction presented by following equations. AgNO3 plus NaCl will be arrow forward arrow AgCl plus NaNO3. The threat that could be taken to obtain pure blood sample of AgCl silver chloride from the mixture includes heating to saturation and dryness, bit drying, filtering and evaporation to dryness, filtering, washing and drying, crystallizing and allowing to cool. AG.
So which one did you pick?
So I think filtering and evaporation to dryness.
Okay. Well, the let's look at the steps. So in the given reaction, the formation of silver chloride as a solid suggests that it can be separated through some steps, a series of steps. And the steps, we can firstly filtering is necessary to separate the solid silver chloride from the solution. Are you listening?
Yes, sir.
So we can talk about filtering as the first step. So then washing helps remove any remaining impurity or soluble substances from the solid. Okay, is that clear? Did you hear that? Did
Yes,
you
sir,
hear
we
me?
did.
Okay, good. So then the next one is drying. If you dry, you after washing it, you dry it to remove any remaining liquid and leaving a pure sample of dry silver chloride. Okay, so the correct option there is C. The correct option is C. Okay, the next question belongs to Moses. So is it Moses or Sarah?
Yes, Sarah.
Okay. So let's see what Sarah is going to do to this next one. So, Sarah, here's your question. Is Taye around now? Can you hear me?
How many electrons does 31 15 P3 contain?
So are you sure the way you put it is correct?
Size it one.
The what?
That 31 and 15 then P3, is it correct? The arrangement.
31, 15, P, 3 minus.
Okay, I understand.
So, what is your
Well, so 18.
18, right? How do you get 18?
Three. So now there's 50 plus 3.
15 plus 3? How? Okay, you just added 15 and 3, right? Who can explain how it is 18? Who can explain?
Explain now.
The question is,
Sorry, the person can explain it now. So I already told you my equipment now.
Who can explain
uh,
it?
sir, I think you know the down one, which is 15,
Mm-hmm.
is is it the proton or nucleus? It can be the
That's my
same.
new place.
It can be the same, anyone guy. So to get it, I
Wait,
think you
wait.
have to
What
do
are you saying,
atomic number
Moses?
equals.
Wait, wait, wait. You said proton, neutron. It can be the same. It can be the same. This 15,
Yeah,
this 15, it means phosphorus has 15 electrons because that's the atomic number.
so
Okay?
proton and electron are the same.
No, they are not.
Proton
Proton
and
and
electron are they the same?
electron, they are the same, but proton and neutron are not the same. Okay? Is that clear?
Yes, sir.
Now, the minus 3 minus shows that it has gained 3 more electrons. Okay?
Electron. Yes, sir.
That is the only condition for us to say, okay, it now has 15 plus 3 electrons. And that's what gives the 18. So you should know the explanation to any answer you are, you know, picking. Okay, the next question for Moses. Let's see this one. Okay.
For me, sir.
For
That
who?
is Moses. Moses.
For Moses, right? I was asking whether Taye is there. Nobody answered. Can you hear me?
Yes, sir.
Okay, Moses, answer the question.
The atomic number of an atom would be equal to its mass number if it the atomic number of an atom would be equal to its mass number if it has a total filled valence shell, has a high charge to mass ratio, does not contain neutron, exhibit isotopy. G, sir.
What do you call it?
G, sir.
So to
D.
mm,
Let's see this. What is mass number?
Ah,
The number
the
of
number of
electrons
the
in the
in the periodic
atom.
table.
Jesus.
Who is answering?
You don't get anything.
What is mass number?
Moses,
So
most
we
said
talk
is the
about.
number.
So
Sir, most said is the number
I
of
did not say
atom
anything
in the
now.
periodic table.
So she's trying to know
Wait.
whether what she's saying is correct. So she's using my name.
Don't tell me what Moses said, though. If you want to answer, just give me your own
Sir,
answer.
most said is the number of atom in the periodic table.
Hello, hello. Mercy. Give me your own answer. What is mass number?
Number of neutrons and nucleus of an atom.
Say it again, please.
Number of proton and electron. The
Proton and
nucleus of an
electron.
atom.
Proton and electron, right?
Nucleus, then the nucleus of an electron. Atom. Ah, Jesus. I'm not doing
It
this.
is not proton and electron, but neutron and proton.
Eh? So you can't hear
Neutron,
you.
but you can see what I have written, right?
Neutron and proton. Say proton.
Plus
Proton.
proton
Proton.
equal to atomic mass or mass number. So, under which condition will, and this one, this proton is the same number of electron, okay? Is that clear?
Yes,
Yes,
sir.
sir.
So, it's equal to the number of electrons. So, if there is no neutron, if neutron does not exist, then mass number equal to this atomic number. Okay? So which of the option is correct?
D, isotopy.
Exhibit isotope. I got it.
You guys just listen to the explanation without making use of the knowledge there. Listen again. Mass number is neutron plus proton. The number of proton is the same as the number of electron, which is the atomic number. Under which condition will the atomic number equal to mass number? When there is no neutron, we can replace E with P, which is atomic number and equals to the mass
Okay,
number.
the answer
So
is C, sir.
the answer is
The
what?
answer is C.
uh
C.
C. Is that clear?
Yes, sir.
I'm hearing only, is it only Moses that is in this class? You want me to ask you to stand up, Sarah and Mercy?
So me, I'm talking now.
Okay, yeah, Sarah, stand up.
Sure.
Stand up, stand up, stand up, stand up. Oh
What
yeah,
to say,
upstand.
stand
I'm waiting.
I'm
up?
scared to
Stand.
move.
I'm waiting. Where is she going? No, let me see you. Want to do what?
Sir, trust me. Mercy.
I need to
I'm
see you
standing.
standing.
He needs to see you say, stand there.
Wait.
Stand. Ah.
Sarah, you want me to
Mercy.
message mommy right now, right? Eh?
Okay.
Sarah, I should message mom that you are sleeping in class and I ask you
Sir,
to stand
message
up.
mom. Speaking.
Stand, stand, stand,
And she
stand.
was hungry. Imagine, sir. Sir,
Angry.
can you stop?
Angry
Yes.
at who?
Me, oh, the I could have stand. I was moving the chair for her. Can you
Okay.
stop? Ah.
Okay. Anyway,
Emily,
this
wait.
reminds me. This reminds me. Are you with me? Are you listening?
Yes,
Yes,
sir.
sir.
The Bible said anger rests in the bosom of a fool. Have you read it before?
Yes,
Yes.
you ready to?
Aha.
Yes.
So I don't know what is making you angry early in the morning. This is 8 minutes to 8. Oh yeah. Wait, you have not even obeyed what I asked you to do, Sarah. I said stand up. You are sitting on something. Look at this girl.
Sarah, stand up.
Okay.
This is my skill.
Oh yeah, return to your chair and sit down. Return to your chair and sit down now, so we can continue. Eh?
Thank you, sir.
Okay. Oh.
What's the demand?
Okay. Oh. Okay. Oh. So you understand this? Let's bring maybe one or two more questions. Who is answering the next question?
Mercy question, Mercy.
Messi. Okay. So for
Yes.
Messi, here's your
Where's the
question.
demand?
No question.
Yes.
Which of the following is not identified as to to achieve more stable electoral configuration between the election?
It will be fully is not.
So I think it's the hybridization of orbitals.
Hybridization. That's correct. That's
Because
correct.
they gain electron, they gain, they lose, and they share.
When they gain, they lose, and they share. They're trying to attain stability. Okay, is that clear?
Mm.
Mm-hmm.
So, but hybrid orbitals are useful in molecular geometry. So, who is answering the next one?
Sarah.
Okay, Sarah, the next one over to you. Sarah, answer this.
Answer your question. That is still active. Answer your question.
Sarah,
Jesus.
Samola mass.
She didn't even read the question. She just put the answer.
Nancy, can you leave me alone? Ah!
Touching you.
who is shouting?
Answer the question.
Who is
It's
shouting?
Sarah.
I'll go at the bottom of the phone. What is
Sarah.
Okay.
I said it's Mola for
Read the
mass.
question. I didn't know.
Let's can you hear me? How do you know that I'm not reading?
Read the question.
It is mass concentration. Okay.
She failed the sick. Name it.
Let's see.
That's
Now, the question above that says which of the following is a which of the following quantity is a molarity? That one, mass concentration in gram per dm cube over concentration in mole per dm cube gives the mass concentration in mass per dm cube over molar mass. Yeah, gives us the molarity. Is that clear? Can you hear me?
Yes, sir.
Okay. And the
Yes,
the
sir.
down part, yeah, the down part. The correct option to this is C. Okay. Dilution factor is the factor by which the stock solution is diluted. So it may be expressed as the ratio of the volume of the final diluted solution V2 to the initial volume removed from the stock solution V1. So it is the total number of unit volumes in which your material will be dissolved. So that is what this is all about. Is that clear now? Can you hear me? Okay. So, and that is what we'll be rounding up. Okay. That's what we'll be rounding up for today. It's a pity that the network has been a little bit the way it is. So we're going to meet.
Sir, said thank you. But you see
Eh,
she still finding her
okay.
face. Yes.
Don't mind.
Look at the
Don't
bottom
mind.
of the phone. The phone, so.
Don't mind Sarah.
Yes, sir.
Okay, so
That be class.
I want to stop this thing.
Yes.
Okay.
Thank you, sir, for the
I think I
class.
saw I saw that you picked
All
my
right.